Caitlin, any ideas? None. None, yeah. Okay. What do you think? Rachel?
Well, plus 1, and then square 2, like how we did with like n plus 1.
Maybe. Should I write something down? What do you want me to write down?
What is that?
That's my phone. It's my good friend Spam, probably. I had this up earlier during my prep. Sorry. Give me some information here. Morgan, you said you maybe have an idea, right? What did you do? I cannot hear you. Okay. Plus the 1, right? All right. So you got to ask yourself, what do I see? Hopefully you see a shape. What is the shape that you see that I have outlined? It's a rectangle. Okay. So this is a 1. Yeah, I almost wish I could write it over here. It's a 1x2 rectangle, and this is figure 1 plus 1 tree. This is a 2x2 rectangle plus 1. This is figure 2. This is a 3x2 rectangle. This is figure 3 plus 1. So if I have 43 trees total, and I see a pattern here, what's the algebraic expression for my pattern? So I say if I had figure n, how would I figure out how many trees there were? Figure n. It's n times 2, because whatever the figure number was, we took that times 2 and then plus 1, right? Does everybody understand that? N times 2 plus 1. And if I was doing this algebraically, I would say 2n plus 1 equals, well, this time I know how many trees there are. How many are there? 43. So I'm going to set that equal to 43. Subtract 1, subtract 1. So 2n is equal to 42. So n, which is the number of the figure, must be 21. Does anybody have 21? Anybody? Did anybody really try the problem? Okay. Anybody have 21? No? Do I have to use algebra here to do this? Could you do some guess and check maybe? Yeah, you could have, but it probably would have taken you a little bit longer. Okay, so you've got to see what the pattern is, recognize it, and then do that algebraically, set that equal to 43, and then solve. Okay? Are you ready to take the test today? Didn't we say that yesterday?
I don't want to miss another class. So if I were to take it, could I take it like, because I don't have a class after this, could I come in like basically 15 and come and take it?
Well, the problem is we have lunch in there too. Can you don't have a class after this? Do you leave early? Like you're done?
But I can stay.
Can you stay after school? Or are you not that far? Not that long. Go ahead and sit down. All right. So, any questions about this? All right, let's go then to page 79. This is our chapter on equations. Equations. I love equations. I love these types of problems. Okay? Of course, you're a math teacher. You have lots of problems. Okay. So, here is our first problem. 3 girls download a total of 36 songs. Okay? So, everybody should be tuned in here. You can tell it's old on their iPods. They're downloading on iPods. Jane downloaded twice as many as Inez. And since Tracy wanted to have the most, Tracy sounds like a Stacy, right? She downloaded one more than Jane did. How many songs did each girl download? So this is on page 79. Page 79. And I'm going to give you 3 to 5 minutes to get started on this. Let me read it one more time. I always think it's important to look at something a couple of times, okay? So let's get our heads up. Sean, heads up, please. Eyes engaged, brains engaged. 3 girls download a total of 36 songs on their iPods. Jane downloads twice as many as Inez. And since Tracy wanted to have the most, she downloaded one more than Jane did. How many songs did each girl download? All right. Take about 3. What is one piece of key information in this problem? 3 girls. Yes, that is absolutely true. We have 3 girls. That's very important to know. What else? Total of 36 songs. Definitely very important. Say it again.
Twice as many as Inez.
Who is twice as many?
Jane.
Jane is twice as many as Inez. And then Tracy wants to have the most. She downloads one more than Jane. All right, let's go back to total of 36 songs. If I'm talking about total, what operation are we using? Addition. Yes, total. So where is that going to go in my equation? Because this chapter is all in equations. Far right side. I mean, you could put it on the left, yes, but yeah, me too. So we know this is going to be a total of 36, right? We have 3 girls. Let's write down their names, okay? We have Inez, we have Jane, and we have Tracy. Okay, now, as we read this again, or as we read this, Jane has twice as many as Inez. So Jane's number is based on whose? Inez. Okay? And then it says Tracy has one more than Jane. So Tracy's number is based on Jane, but Jane is based on Inez. So who is our main person here that everything really is based on? Inez. So Jane has twice as many as Inez. So what amount should we put down for Inez? What should I put down for Inez? N for number. She downloads N number. We don't know what it is. We're just saying it's a variable, okay? Jane has twice as many. What? What about it? He came up with this one, you think? If Jane has twice as many, how are we going to show her amount? 2n. Because we don't want to have 3 variables. Have you ever tried to solve a 3-variable equation? It's not very fun. And then Tracy has, what does it say?
One more than Jane.
How do I show 1 more than Jane?
1 plus 2. So
1 plus 2?
it's just like 3.
1 plus 2? 1 plus what? How much does Jane have? Okay, so start with that. 2n plus 1. Is that 3n? No, you can't combine those terms.
Oh, no, 2n plus 9.
Mm.
It would be more.
It's plus 1. It says she has 1 more than Jane did. So if Jane has 2n, I have to say just 1 plus 2n. Right? That's 1 more. Okay. So what do I do with these fantastic expressions? Combine them. So we have Inez has n plus Jane has 2n plus Tracy has 2n plus 1, and that all equals 36. You were not right, Chris. Come on. Jeez. Now what? Combine your like terms. You got an n, a 2n, and a 2n. So how many n is that?
5n.
5n, yes. And if you're not sure if you can add, call it something that starts with that letter. I have 1 nickel plus 2 nickels plus 2 nickels. That is a total of 5 nickels. Plus 1 equals 36. Can we solve that equation? I sure hope so. So subtract 1 from both sides. Hey, can you write this down? Shmaya, at least write it down. 5n is equal to 35, and so n is equal to 7. I am finished with the answer.
You gotta say,
Or am I?
no, you said, you gotta answer the other question.
What's the other question?
How many songs did each girl?
Oh, so Inez was equal to n, so how many did she download? 7. Jane is equal to 2n, so that would be 2 times 7, which is 14. And Tracy is 1 more than that. You could say 14 plus 1 is 15. How can I make sure that all these numbers are right? Add them up and they should total 36. Do they? They do. Boom. So you can't just leave it at n equals 7. You've done a lot of great work up till then, but let's not forget what's the question they're asking for. Okay? Do you guys think you could do that on a test? Just say yes. Yeah. Yeah. Okay. All right. Well, let's go to the next one. Let's see. Here we go. Task number 2. A checking account is set up with an initial balance of $4,800. $300 is removed from the account each month for rent. No other transactions occur on this account. How many months will it take for the account balance to reach $1,500? Somebody else said that last period. So this is not the place where I'm looking for the Staples easy button. You know what? Here's my little talk. Everything's easy if you know how to do it. And some of you that have had me before, you have probably heard this before. Tying your shoes is really easy unless you're a 3-year-old and you don't know how to tie your shoes. Pre-calculus is really easy if you know how to do it. If you don't know how to do it, but if you know how to do it, it's easy, right? So I would like us to refrain from saying that something is easy, because for some other people it might not be. I'm glad for some of you it seems to be easy, but let's try to stay away from that. People just haven't learned it yet. Okay? All right, so take a couple minutes and see if you can come up with an equation. I need an equation. I need an equation. Because we could have used guess and check on the last one, but that's a lot of guessing and checking. Chapter is on equations. So we're trying to form an equation to get to our answer. So you can say B for balance, but we know what the initial balance is. So that's why we included that. We're saying 300 is removed. That's the subtraction from the account each month. So if I did 1 month, that would be 300. If I did it for 2 months total, that would be 600. But we don't know how many months, so that's why I'm putting in that variable. And usually whatever they're asking for, that's what your variable is going to be. Okay? And we're trying to reach 1500, so that's what I'm putting on the other side. So I totally get what you're saying. And it's just once you work with them a little bit more, I think you'll be a little bit more comfortable. Okay? But I'm glad you got the right answer. Really. All right, so how do I solve this algebraically?
Subtract 480.
Yeah. My variable is here, and it's the only variable term I have. So I'm going to keep the n there, and I'm going to subtract 4,800 from both sides. Miss Thady, do we really need to show this? Yes. Algebra skills are important. So negative 300 times n is equal to negative 3,300. And this is where you probably divide it by negative 300, divide by negative 300, and n is equal to 11. 11 what? Months. And you will also find out the longer that you have me, I am a stickler for, yes, you really should label. Are we talking about pink flamingos or tutus or what? Question, Isaiah.
I didn't exactly like that. But,
okay.
Yeah, see, I put like, so 4,800 equals 300 plus 1,500. Yeah.
And did you leave it like that?
And I received the same answer.
Well, the only problem with this is that 300 and 1,500 does not equal 4,800. So you got to have that variable in there. Oh, and X, whatever. Okay, perfect. Yes, that is absolutely the same. I'm sorry?
You should substitute to double check.
I should substitute to double check?
Yeah.
Do you think I should?
Yeah.
How would I do that?
Substitute 11 to n.
Uh-huh. And we would get 4,800 minus 300 times 11 equals 1,500. And this is where I would need a calculator. 4,800 minus, oh no.
Negative 3,
I guess it's 3,300, isn't it?
Yeah.
Equals 1,500. Remember, you always work down. So 1,500 is equal to 1,500. Boom. There you go.
You could say that would be
Okay.
infinite solution or something like that.
What? Okay, pause for a minute. Let's go to the last question. I really want to see if you can do this. Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. If you add together the ages of Justin, Peyton, and Matt, the total comes to 39 years. How old are Justin, Peyton, and Matt? You told me you thought you could do this from the first one. Guess what? Boom, show me you can. Try it again. Try it again. We have about 4 minutes. Yes, you can get this done in 4 minutes. I'll read it one more time. Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. If you add together the ages of Justin, Peyton, and Matt, Justin, Peyton, and Matt. Wonder where they got the name Peyton. You will get 39 years. Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. What is an important piece of information here? Peyton is 3 years younger than Justin. What else is important?
Matt is 4 times as old as Peyton.
Boy, you're talking like I am. Matt is 4 times as old.
Yes.
Get it? Times. Okay, good. What else?
Total comes to 39 years.
Total. So where am I going to put that 39?
Farther right.
To the far right. To the right. To the right. Yes.
How old are Justin?
Who is this whole problem going to be based on then?
Justin.
Matt, Peyton, Justin. I think I heard all 3 names.
It didn't say how old, like, say something about Justin's age. Just say they're old.
Well, yeah. Who's this based on though? Justin? Peyton? Peyton is 3 years younger than Justin. So isn't his age based on Justin? So I think the answer there is Justin. And we'll come back tomorrow and pick this up. Okay? You